Hello G, in this video we will try to make medium pi transmission line on Matlab. So on Matlab Simulink to be precise. So for that purpose you need components, and the thing to remember is while choosing component, make sure that all the component that you pick should be from the same library, because sometimes what happens is if you choose components from different libraries, it won't connect on the Simulink while with the Y. So for the for today or for this video, I would try to choose component from Simscape library. And to be precise, as I'm doing with power and the transmission line, I need the component from the power side, or you can say that a high voltage or high current type, high rating component. So for this you have same power system library in the Simulink. So what you need to make a transmission line? In the elements, what I need is first uh, capacitor, inductor, and so for that purpose I would take a series RLC branch and add it to the untitled. Mm, Similarly, I would need a capacitor in parallel. So for that purpose, let me take another capacitor from here, and yes, I need power source. Power source from where I can take a power source. Power source. Yes, you have the option of electrical sources. Here you can say you can take AC voltage source and add it to the title. So I need load, but for now I think it would be enough. I would take it if I need in another time. Except that you need a GUI component, power component. Without this component, the transmission line, the transmission model that you make will not run. So yes, power GUI. So I will add that too. Now let's go to the models. So I have a power source. Let me enlarge it. So here's my power source. So I need resistance and inductance in series, but as you can see here, there is a capacitor too. So I need to eradicate or root out, or you can say that, and the capacitor from here. So you can just simply double tap it and mark only on RL, so the capacitor will disappear. And I need two capacitors in parallel before and after that branch, so I would just simply rotate it. Where is rotation option? Yes, rotate. Yeah, I have rotated it, and I need copies of it on both sides. So again, I need only capacitors here, so I would double click it and click it on the capacitor only. Now I would take its copy and place it after that branch too. So here I have two capacitors. Now I simply need to join them. Let's join them. See, if you have taken the component from the other libraries, they won't have, it wouldn't be possible to join them with the wire, as I have said earlier. So here is the model of transmission line. I need a load. Let's say I take it as a load, or I simply go to the components and take the load from that, from the same library. Yes, and from the same library I need elements. Go to the elements and take a resistive load. Here you have parallel RLC load. You can utilize it as a simply resistive load. So just rotate it. Where is rotation option? Yes, ये रोटेट हो चुका है, और इसमें से आपने सिर्फ as you need only as it's load, so you are given with all the load type options. It's power rating, real and apparent power, inductive, reactive, हर तरह की power. So क्योंकि आपने सिर्फ resistive लेना है, तो आपने इसको भी ज़ीरो कर देना है, कैपेसिटिव को भी ज़ीरो कर देना है, तो आपके पास सिर्फ resistive बच जाएगा. So you are here with only resistive, so join it with the Y. Oh, so one thing is missing. You need a ground too. So take the ground from the same library, add it to the project you are making, or simply इसको join कर. Now if I run it, it would I think give me an error. Let's see. If I run it, I hope it will give me an error. Yes. What it says that voltage AC cannot be connected in parallel with the capacitive element defined the block. So add a small resistor in series with the voltage source block or so. What it's saying that it won't run until you add a resistive source in series with resistive element in series with the voltage source. So I would do the same. I would take a resistive source. Let's say I would simply copy it and paste it, and I need only resistive, so I would mark on the resistance only. I would rotate it. I will rotate. Where is the rotation option? Yes, I have rotated it, decrease its size, and simply connect it with the voltage source. So break it from here, connect from here, and join it from here, and decrease the value to as minimum as possible. So I have taken 0.01 in micros, you can say. Now run it. I guess it will be okay now.